Thank you so much for your time and interest. So one of the dynamics that we've looked at recently in our research and are sharing in this memo titled Nickel Market Dynamics and the Security of the Battery Supply Chain is the fact that there's been a rapid growth in demand for nickel due to its use in battery cathode materials. So use in the battery sector has grown by 200% in the past 5 years, with the battery sector's share of total demand growing from 5% to 15% over that same time period. For decades before, nickel consumption has been dominated by the steel sector, so this shift in the market has been quite striking recently. And this is particularly important because the grade of nickel relevant to the battery sector is of higher purity requirements than the majority of it. So estimates indicate that by 2050, it could be that more than half of nickel produced may be used in battery applications. In particular, the International Energy Agency's net zero emissions scenario, which is a scenario that represents clean energy deployment needed to meet climate goals that limit global warming to 1.5 degrees Celsius, projects a 10 times growth in demand from electric vehicles till 2040. So based on this significant growth and shift in demand, the supply chain for nickel is going to have to respond.
Thanks, Elsa. Historically, the supply for battery-grade nickel has come from sulfidic ores, which are smelted into a nickel matte, which is further refined and then dissolved to make nickel sulfate, which is the precursor for cathode active materials. However, there have been very limited discoveries of new sulfidic resources, and most of the large high-grade resources are currently already being extracted. So in the recent past, most of the growth in nickel sulfate has come from laterite mining, which is dominated by Indonesia, who have the highest amount of laterite reserves. There are two kinds of lateritic resources, saprolites and limonites. Saprolites typically have a higher nickel content than limonites. Saprolites have been historically converted to nickel pig iron or ferronickel which is classified based on the amount of nickel content via smelting. And that process is quite carbon intensive, especially in Indonesia, which relies on coal in that smelting process for both energy and as a reducing agent. More recently, over the last couple of years, this nickel pig iron and ferronickel is being converted to a nickel matte, which is a nickel sulfur alloy. And that nickel matte is then converted straight into nickel sulfate through an electrochemical process. And the other pathway that has been deployed to convert lateritic resources to nickel sulfate is through the leaching of limonite resources. So there is this process called high pressure acid leaching, HPAL, that converts limonite ores into mixed hydroxide or sulfide precipitates, and these are then converted to nickel sulfate. The challenge with using HPAL is that it generates a large amount of waste. So it's estimated that 1.4 tons of waste is generated per ton of nickel produced, and managing those tailings is hard, especially in an earthquake-prone and heavy rainfall region like Indonesia. So there has been a huge shift in the supply of nickel that is used to make nickel sulfate from sulfidic resources to both saprolites and limonites. And this shift represents an increase in a confluence of geopolitical, economic, and environmental risks in the nickel supply chain. So as you can see on the figure on the left, Indonesian mine production has been increasing rapidly, and 50% and growing share of global nickel production is now from Indonesia. Moreover, from a geopolitical point of view, a large amount of the new nickel projects that are battery grade, so either the leaching projects or the matte sulfidation projects that are coming online, are owned by Chinese firms. So there has been a huge amount of investment by China in Indonesian projects. And there's a very strong trade relationship between Indonesia and China, which also happens to be the largest producer of nickel sulfate in the world. And finally, because of this growth in Indonesian supply so rapidly over the last few years, prices have been going down. And these lower prices are leading to a curtailment of mine production in other regions across the world. So it presents an economic risk to building a diversified and secure supply chain. Along with these economic risks, as we already alluded to previously, there is a combination of environmental risks that are growing from the new processing pathways that are coming online for nickel. In both of the laterite cases, laterite smelting, which converts NPI to matte, there is a significant amount of carbon emissions, which can be up to 6 times greater than sulfide smelting, which is the historical route to making nickel sulfate. And because of the fact that a sulfidation converter is used, a large amount of sulfur dioxide is also released in this process, which has to be managed. And can, without that management, can lead to terrestrial acidification impacts. On the other hand, laterite leaching, as I mentioned previously, has a large amount of waste generation, and managing that waste also leads to larger land use impacts. So there's this confluence of the environmental risks that are growing along with the geopolitical and economic risks. So dealing with these multiple risk factors requires coordination between stakeholders on the demand side and the supply side, as well as policymakers who can help navigate these risks and promote a market that builds a more sustainable nickel supply chain.